This lesson is on dilations. It's the fourth kind of transformation we're studying, the other three being reflections, translations, and rotations, all of which are congruence transformations or isometries. Dilations, on the other hand, are similarity transformations, because while the shape, the angles of a pre-image are preserved, as you can see with these examples here, the size is not, and therefore it's not a congruence transformation. We have two kinds of dilations. One is a reduction, that is the pre-image, in this case the lighter one, gets smaller, it's reduced, and therefore a reduction. The opposite case would be an enlargement where our pre-image becomes larger, therefore an enlargement. As you've learned with similarity, we have scale factors in this situation. If the scale factor is between 0 and 1, or technically if its absolute value is between 0 and 1, we have a reduction. If the scale factor is larger than 1, we have an enlargement. Okay, the examples are quite simple. If the blue is a dilation of the red, that means the red is the pre-image, and we go from a large object to a small object. So clearly this is a reduction. To determine the scale factor, as you would in the chapter on similarity, you simply pick a length of a side of the image and divide that by the corresponding side of the pre-image. Okay. The image is 5, the pre-image is 10, and therefore that simplifies to 1/2, or a scale factor of 1 to 2. In this situation, the green is a dilation of the blue, so we start small and end up with the large one, and therefore this is obviously an enlargement. So I'm going to pick the larger side, and the parallelogram, the sides, this top side is apparently 3 times 3, or 9 long, and then the blue is 3. We compare those two, so the scale factor is 3 to 1. Okay, we can tell by this picture, since we have A and B, that we're looking at the pre-image. We are told to find the length of A prime B prime if the scale factor is 1/3. We can't see A prime B prime, but if the scale factor is 1/3, you can imagine seeing this pre-image 1/3 its size. That would be the image. And so to find its length, we simply multiply this length by the absolute value of the scale factor. The absolute value of 1/3 is 1/3, and 6 times 1/3 is 2. So if the star were 1/3 its size, side AB, or A prime B prime, would be too long. In this situation, I'm imagining something very similar, except for I see the finished product. I see the image. Okay, and if this side is 6, the scale factor is -2. That means I took however long it was to begin with, which was AB, and I multiplied that times 2, and I got the new length, which is 6. To find the old length, I simply divide by 2. Okay. Frequently, your homework is going to require you to find the new coordinates of a dilated image. We haven't spent much time talking about the center of dilation, but for our purposes, the origin will almost always serve that purpose. As you can see, each individual point, if we're starting with the blue pre-image and the scale factor is 2, essentially everything's going to get twice as far, that is 2 times as far from the origin. And you can see that by looking at the pictures. 4, 0 is twice as far away. 0, -5 is twice as far away. -1, 2 is twice as far away. The way we find the new coordinates is simply to multiply each of the old coordinates by the scale factor. So for example, if we have the point -1, 1 and a scale factor of 3/2, we just multiply -1 by 3/2, and we multiply 1 by 3/2, and we find the new coordinates.